program will introduce you to the 757 EFIS, the Electronic Flight Instrument System. EFIS has been designed to simplify cross-check requirements during all phases of flight by consolidating reference items on single-source instrument displays. EFIS includes the Electronic Attitude Director Indicator, EADI, the Electronic Horizontal Situation Indicator, EHSI, the symbol generators to drive the indicators, and the associated control panels for these instruments. The EADI and EHSI use cathode ray tubes, or CRTs, to display information in 7 colors. They are more reliable than their electromechanical counterparts and more versatile, with selectable information and modes not previously available to the flight crew. The information displayed on the EADI and EHSI is provided by 3 symbol generators. These generators are used to process sensor navigation and guidance data. Source selector switches are located on the captain's P1 panel and first officer's P3 panel. The switches select which symbol generator drives the EADI and EHSI displays. The left symbol generator normally provides control signals to the EADI and EHSI display units for the captain. The right symbol generator normally provides control signals for the first officer's display units. A center symbol generator is provided as an alternate or backup unit for the left and right symbol generators. It is physically and electronically identical to the left and right units. Pushing the EFI switch to the alternate position selects the center symbol generator to provide display signals to the captain's or first officer's display units. Other switches on the instrument source select panel may also select the source of data into the symbol generator. If both the captain and first officer select the same symbol generator, a level B caution message appears on the upper ICAST display and an associated oral tone sounds. This message indicates that the first officer's EADI and EHSI are now controlled by the captain's controls. The symbol generators are mounted on the E2 rack in the main equipment center. A test switch, located on the front of each symbol generator, provides a test pattern for checking on the EADI and EHSI to check system performance. Next to the test switch, a reset switch is used to reset the byte fault memory. Information from the symbol generators is managed by separate control panels on the forward control pedestal for each pilot's instruments. The upper panel controls the EADI, while the lower panel controls the EHSI. EADI and EHSI display brightness is adjusted manually using the brightness controls. After the brightness is set to the desired level, 2 remote light sensors located on the P7 glare shield panel and local light sensors mounted on the EADI and EHSI maintain the selected intensity throughout varying light conditions, including direct sunlight. Power for each EFIS component is controlled by individual circuit breakers on the P11 overhead panel. Now, let's take a closer look at the CRT displays, starting with the EADI. A conventional ADI, displaying primary attitude, is now presented in this electronic format. Command bars display flight director computed roll and pitch commands. Taking advantage of the CRT's capabilities, flight-related information is conveniently and selectively shown on the EADI periphery. Ground speed is presented for all ground and flight operations. Airspeed deviation is shown, normally referenced to the command airspeed bug. Autothrottle and autopilot flight director status, modes, and speed limits are shown in the lower corner annunciations. Important autothrottle and autopilot flight director mode changes are emphasized for 10 seconds by a green box appearing around the changed mode. Localizer and glide slope deviation scales may be selectively displayed by the pilot. After localizer capture, the localizer deviation scale automatically changes to an expanded presentation 4 times as sensitive as the standard deviation presentation. Glide slope deviation is shown on the right side scale. Decision height and radio altitude are displayed in the upper right corner. The decision height is selected on the control panel, which also sets the corresponding EADI display value. When the airplane passes through the decision height, the number becomes a flashing DH, and both decision height and radio altitude indications change to amber. Now, let's look at the EHSI. The conventional HSI that you have used in the past shows the relationship between the airplane and an en route or approach course. The EHSI in the new airplane can present this same information electronically in several different modes. In the full ILS mode, heading, localizer, and glide slope are provided in a familiar format, and tuned ILS frequency is displayed here. For all modes, a digital readout in the box above the compass pointer displays the compass pointer value in either magnetic heading, shown here, or magnetic track, which will be discussed later. Also, for most modes, relative wind direction and velocity are displayed. Let's take a closer look at the EHSI display versatility. As mentioned earlier, the EHSI can be operated in various modes as depicted on the mode selector. We've seen the full ILS mode. Now, let's examine the full VOR mode. This display is similar to the previous mode, but has conventional VOR course deviation and to/from indications. By looking at the essential information in the top half of this full VOR display, the expanded VOR mode improves this presentation with a new uncluttered display. The airplane symbol, now a triangle, is at the bottom of the display. The compass rose is now shown across the top as an expanded 70-degree compass arc. A dotted line extends from the airplane symbol to the selected heading marker. The marker is controlled by the heading selector on the glare shield mode control panel. A conventional course deviation indicator is used. A line projects from the course pointer to the desired course on the compass arc. A track line extends from the airplane symbol to the compass arc to aid in course tracking. In the expanded ILS mode, the display is almost identical to the VOR mode, but shows localizer course deviation. As in the full ILS mode, it also adds glide slope information on the lower right scale and tuned ILS frequency. The map mode aids the crew in maintaining a mental image of their flight path by presenting route information against a moving map background. The orientation is now track up along the current track of the airplane. The track line becomes a cursor, projecting from the airplane symbol directly to the box, which now displays magnetic track. Drift is shown as the difference between the magnetic track and the heading pointer, which shows the actual airplane heading. The number at the midpoint of the track line represents 1/2 the map display distance coverage as selected by the range selector on the EHSI control panel. The range can be varied from 10 to 320 miles. The flight plan defined waypoints are shown as stars. A solid line representing the flight plan route connects each waypoint. When a waypoint becomes the next one being flown to on the flight plan, its color changes. Flying the track line cursor over the flight plan route simplifies the course tracking task for the pilot. During turns, a trend vector displays projected flight path based on bank angle and ground speed. Up to 3 segments may be shown depending on map range, with 30, 60, and 90-second positions indicated. distance in nautical miles, and ETA to the waypoint currently being flown to on the flight plan are also shown. The final EHSI mode is Plan. It shares some features with the Map mode. Visualize a line across the top third of the CRT. Information above the line is identical to the Map mode display. The data below this line are map and flight plan information oriented north up for flight planning purposes. The information display is similar to that presented on navigation charts. This arrangement allows the crew to monitor flight conditions while planning. The Plan mode may be used when reviewing a flight plan to step through and examine each leg. Now, let's look at the other controls associated with the EHSI. Pushing the weather radar switch displays weather radar returns in 3 colors. In the Map mode, as the range selector varies the range and scale for the display, the weather returns change accordingly. The flight crew can now directly relate their route to any significant weather ahead. This feature is only available in the Map, Expanded VOR, and Expanded ILS modes. The Map switches allow selectable information to be displayed on the EHSI in the Map mode. For example, pushing the Nav Aid switch brings up additional navigation stations on the selected map segment. Pushing the map switches a second time removes the added information. When the route data switch is pushed, mandatory crossing altitudes and ETAs for the flight plan route waypoints appear adjacent to these waypoints. The map switches may be selected individually or in combination. This enables the crew to control EHSI display information and clutter. To summarize, this program has been an introduction to the Electronic Flight Instrument System, or EFIS, which consists of the EADI and EHSI cathode ray tube displays and their controls. The EADI displays primary attitude and flight director steering bars in a conventional format, while flight-related information is conveniently and selectively shown on the instrument periphery. The EHSI can present pilot selectable information in conventional VOR or ILS formats, expanded and simplified VOR or ILS displays, and unique map and plan modes. Selectivity of the CRT information is accomplished through control panels provided for each pilot. This completes this program. You have seen the location and function of each of the major components in the system and have been given a basic description of the system operation.